Its power is greater than all hydrogen bombs. Its speed is higher than any rocket ever conceived. Its force can shatter continents. Its mass can level mountain ranges. It cannot think, it cannot reason, it cannot change its course. This is how an impact event was described in the 1979 movie Meteor. While an impact event may seem like a work of science fiction, the truth is we're all equally vulnerable to an asteroid strike as the dinosaurs were. Planetary defense is the term used to encompass all the capabilities needed to detect the possibility and warn of potential asteroid or comet impacts with Earth, and then either prevent them or mitigate their possible effects. NASA established the Planetary Defense Coordination Office, or the PDCO, to manage its ongoing mission of planetary defense. The key element of NASA's planetary defense effort is the Near Earth Object, or the NEO, Observations Program, which is composed of projects to find, track, and characterize NEOs. It employs a variety of ground and space-based telescopes to search for NEOs, determine their orbits, and measure their physical characteristics. The NEO population is quite diverse, a fact which presents significant unknowns. When considering how to develop technologies capable of deflecting or disrupting the object, observations including optical and planetary radar over many years may improve our understanding of the composition, mass, and behavior of any particular object, which in turn could improve design of the deflection technologies. The Wide Field Infrared Survey Explorer, or WISE, is a NASA infrared wavelength astronomical space telescope. Active from December 2009 to February 2011. The initial mission length was limited by its hydrogen coolant, but a secondary post-cryogenic mission continued for 4 more months, with 2 of the 4 detectors remaining operational. In September 2013, the spacecraft was reactivated, renamed NEOWISE, and assigned a new mission to assist NASA's efforts to identify and characterize the population of near-Earth objects. The NEOWISE project has delivered physical data on an enormous number of minor planets, and efforts are underway to mine even more out of the dataset. So far, NEOWISE data have been used to constrain the number, sizes, and orbital elements of NEOs. Efforts were undertaken to perform detailed analysis of small body thermophysical properties, as well as the dust and gas properties of active bodies. To learn more about asteroids, the origins, spectral interpretation, resource identification, security, Regolith Explorer spacecraft will travel to a near-Earth asteroid called Bennu and bring at least a 2.1 ounce sample back to Earth for study. The mission will help scientists investigate how planets are formed, how life began, as well as improve our understanding of asteroids that could impact the Earth. OSIRIS-REx was scheduled to launch on September 8, 2016. As planned, the spacecraft will return a sample to Earth in 2023. Have you ever fantasized about deflecting a celestial body with your powers? Well, the good news is that you don't need to be a superhuman to accomplish this, because NASA is set to turn this fantasy into reality. The Double Asteroid Redirection Test, or DART, mission is directed by NASA to the Applied Physics Laboratory, APL, with support from several NASA centers. DART is a planetary defense-driven test of technologies for preventing an impact on Earth by a hazardous asteroid. It will be the first demonstration of the kinetic impactor technique to change the motion of an asteroid in space. The binary near-Earth asteroid 65803 Didymos is the target for the DART demonstration. The spacecraft will achieve the kinetic impact deflection by deliberately crashing itself into the moonlet at a speed of approximately 6.6 kilometers per second. With the aid of an onboard camera named Draco and sophisticated autonomous navigation software, the collision will change the speed of the moonlet and its orbit around the main body by a fraction of 1%, but this will change the orbital period of the moonlet by several minutes, enough to be observed and measured using telescopes on Earth. The DART spacecraft launch window begins in late July 2021. DART will launch aboard a SpaceX Falcon 9 rocket from Vandenberg Air Force Base, California. As with the other low probability, high consequence hazards, potential annual impacts pose a significant and complex challenge. The strategy is a step in addressing the myriad challenges of managing and reducing the risks posed by both large and small NEOs.